trig, it has to have this 90-degree angle for all of these statements to be true. And we never use the 90-degree angle as a theta. So a theta is the angle we're talking. We could put theta anywhere we want. I put it right here in this left corner. And then we know if it's a right triangle, we can do Pythagorean theorem for outside of the outsides of the circle. We can do Pythagorean theorem. We can also set up right triangle trig, which is sine, cosine, tangent. And we memorize the trig ratios. Ratio means division as SOH. So sine of theta is opposite over hypotenuse. See the so? Everyone remember this? Yes? Yeah. So go to theta and go opposite from theta. Look, it's literally very literal. What's opposite of that? 4. And then the hypotenuse is always across from the 90-degree angle. So wouldn't it be 4/5? Yeah. Cosine is adjacent over hypotenuse. So your adjacent side is like this. It's not opposite. So the not opposite side's adjacent, which would be 3, and the hypotenuse is 5, right, everyone? Yeah. Tangent is opposite over adjacent. Our opposite side is 4, and then our adjacent side is 3. If your fractions simplify, you're going to be asked to simplify to get full points on your test. Of course you are. Now, make sure that you understand if they say, what's sine of theta? You stop there. You write out the ratio. You don't then solve for theta unless you're supposed to be solving for theta. Now remember these reciprocal. Reciprocal is not inverse. It's not the same thing. Reciprocal means fraction flip. So cosecant is considered the reciprocal of sine. So you literally will just do h over o. So that would reciprocate that. So that would be 5/4. Cosecant is the reciprocal of cosine. So it would be ha. So then that would be 5/3. And cotangent's the easy one to remember is the reciprocal of tan. So then that would be a over o, which would be 3/4. Okay, questions? Moving on. Okay, so read this problem because on the test you can't get these confused or you're going to be solving the wrong things for the wrong thing. So it says find sine of theta, cotangent of theta. So you're going to say, what is theta? Well, isn't this apparently theta, everyone? Yes? So then if you need to label it, go, okay, straight across from this will be considered opposite. Across from the 90 is hypotenuse, which means this is adjacent. So then it says find sine of theta. So if this is find sine of theta, you'd say, okay, it's so opposite over hypotenuse. Our opposite side was 24. Our hypotenuse is 26. Is that right? Yeah. And then they both divide by what? 2. So if they both divide by 2, that would become 12/13. Cotangent, this is my thought process, is the reciprocal of tan. I write down tangent first. So I say tangent is TOA. So it's opposite over adjacent. So this one will be adjacent over opposite. My adjacent side is 10. My opposite side is 24. Then we can see these both divide by 2. So that'd be 5/12. Now, don't keep solving for theta. There's always the kid that then solves for theta. It said find sine of theta, not find theta. Okay, so look at the next one here. Find cosine theta, tangent of theta. So look, notice it's missing a piece. You would say, oh, okay, if I'm missing a piece of the right triangle, as long as it's side lengths, I can do Pythagorean theorem. A squared plus b squared equals c squared, where c has to be the hypotenuse. So we're doing 4 squared plus 2 squared equals c squared. So it'd be 16 plus 4 equals c squared. 20 equals c squared. You need c, not c squared. So wouldn't we square root both sides? Yeah. So that would be 4 times 5, which is 2 times 2 times 5. So this will become 2 roots of 5. We know that when solving by taking square roots, we need to be putting a plus and minus. But in the context of this problem, it's a side length. There are not such things as negative side lengths. From here, we answer the question. So I'm going to write myself a note. So, TOA, just so I have it right there. So cosine is adjacent over hypotenuse. My adjacent side is 4. My hypotenuse is 2 square roots of 5. Before you do anything, simplify anything that simplifies. We're allowed to divide across multiplication signs. Isn't this a time sign? Then divide correctly. Isn't 4 over 2, 2 over 1? So we have 2 over root 5. Now, technically, if you leave your answer like that, it's technically not considered simplified because we're not supposed to leave radicals on bottom. So now we're going to rationalize the denominator. So we're going to fix this by timesing by root 5 to the bottom and to the top. So on top, we get 2 root 5 over what number? 5, because it's the square root of 25, which is 5. Okay, I'm going to do tangent next. So tangent is opposite over adjacent. Opposite over adjacent. Wouldn't that be 2 over 4? Is everyone seeing that as quickly as I am? Yeah. Opposite. So, okay, good. And then cotangent would be the reciprocal of 1 over 2. So what would be the reciprocal of 1 over 2? 2 over 1, which is 2. Excellent. Questions? Easy, hard? What do you feel? Okay, good. All right, so now look at this. Okay, it says solve for x. We're not at the homework yet. Solve for x. What you're going to do is say, I'm going to pick a theta. Pick any theta you want except 90 degrees. Wouldn't it make sense just to pick the one given, 62? I could use the other one, but then I'd have to do 180 minus 90 minus 62, and that's extra work. So if that's your theta, then label it. What is this side considered? Opposite. What's this side considered? Hypotenuse. So then you say, I'm either using so or ka or toa. It's just one of them. So it's based on the information given. Aren't you doing opposite and hypotenuse? So which one has opposite hypotenuse? So write down the true statement. Sine of theta equals opposite over hypotenuse, and then fill in the unknowns. So we're going to say sine of theta is really in parentheses. I'm being lazy, like a lot of textbooks are. Really, it's really sine of theta like that. So we would say sine of 62 degrees is equal to the opposite, which is 15, over the hypotenuse, which is x. See, now we have a statement with only one unknown. X is the only unknown. And now this is basic algebra. Get x alone. So it kills me because I'd get secondary 3 students from secondary 2 where you guys are at, and you won't be these kids, and they could not solve this. This is basic like algebra. This is like 2nd grade algebra. How do you get x out of a denominator? So times x over here. So then you have x sine of 62 equals 15. You guys remember, sine of 62 is just a number. It's just a calculation. We're not going to do the calculation yet. Get x alone. Yeah, divide by sine of 62. Divide by sine of 62. And then, now we would say this. On the ACT, they would go x equals 15 over sine of 62, and they would leave it like that on the ACT, but this isn't the ACT, so we would type it into our calculator. Make sure your calculator's in degree mode. Hi. Perfect. It's on the board, ready to go. You can grab it, and then just find a seat amongst these guys somewhere.
Will it change, like if we just always leave it in the degree mode?
It should be fine for what we need to be doing at our level of trig. Degree mode's going to be where we're at. When you get to secondary 3, there'll be times when you need to switch it to radian mode, but not at our level. 16.98. I'm just doing 2 decimal places. I didn't even round that correctly. We're going to try to do better on the test. Questions on that one? Okay, so look at this one. Just hit mode and then go down to degree. So this time I'm going to pick theta as 62. That one's like the same, isn't it? Yeah. It's not the same numbers, but let's not do that one. Let's do this one. Okay. So right here, pick this one as your theta. It's kind of fuzzy. I think that's 64. So now from here, isn't this adjacent? Yeah. And this is hypotenuse. So is it so, or is it ka, or is it toa? So you would say cosine of theta equals adjacent over hypotenuse, and then fill in the unknowns. So cosine of 64 equals adjacent over hypotenuse. Now the algebra on this one's even easier than the last one because this time x isn't in the bottom, it's in the top. This is basic algebra. Don't overcomplicate it. Get x alone. Right? So what are we doing? So 16 cosine, and order doesn't matter, so you could write cosine 64 times 16 equals x. This is what you would see on the ACT, but again, I have noticed now ACT is becoming online, and they are providing calculators, so actually, I think they might move in the direction of everyone has a calculator, so it's equal. Like, I think they might even move into putting more answers like this, just because they provide a calculator on the online ACT. So they actually can do answers like that nowadays. Questions? Was that easy? Feel okay? Yeah. All right, I think we'll move on past those ones, but what I want to do is, I have no idea why, guys. These are not hard, but look, people overcomplicate these. So watch. It says solve for the unknown piece. So you'd say, well, the unknown piece must be theta or x. So in this case, it's theta. If you want to call it x, call it x. It doesn't matter. It's a variable. Theta is just a variable like x. It's just Theta usually stands for angle, so they're using that over x. But either way, if they put x at an angle, we'd be solving an angle. From here, you would say, I'm going to use this as my theta. So if that's my theta, is this opposite or adjacent? And then isn't this adjacent? Again, you say I'm either using so or ka or toa. One of them will work. Only one. Toa, opposite and adjacent. So you're going to write in like this. Tangent of theta equals opposite over adjacent, and fill in what you know. This is the first time our theta is an x. I switched it out for an x. So our opposite is 10 and our adjacent is 9. So now the algebra is not as straightforward, but it's not hard, guys. Look. So you're right. To get x alone, isn't it trapped inside tan?
Yeah.
Now, I told you, we learned this year, the only way to undo tan is to apply the inverse. This is not a multiplication problem. This is a trapped in parentheses problem. The way we undo tangent is apply tan inverse to it. So you go tan negative 1, which is really tan inverse of both sides. Now, on the left side, it literally just cancels out the tan. So you have x equals, and you have to understand that when you take tan inverse, all that stuff goes in the parentheses of the tan inverse. So when we apply tan inverse to 10/9, it's then trapped in the parentheses. And now it's literally a calculator problem. We go second tan, because that will pull up inverse on our calculator, 10/9, and I get 48.01 degrees. Solving for theta, solving for an angle is the only time you're going to be doing an inverse. Questions on that one? If you're finding an angle, you're going to need the inverse, unless you already have two angles. So let's do maybe one more just like that. So this one is opposite. This one is hypotenuse, isn't it? If they said solve for theta, you'd say, I'm going to use so. So you would say, okay, so sine of theta is equal to opposite over hypotenuse. Then your mindset should be, okay, theta is trapped inside sine. I need to get rid of sine. The only way to get rid of sine is to apply the inverse. So I sine inverse both sides. Now, a lot of people think that's hard because they don't get it. They're like, well, I don't get why. That's a memorization thing. You're not understanding why that is. So this cancels out, and we have theta equals sine inverse of 13 over 15.7. The calculator's been programmed to calculate what sine inverse is. So you don't need to know why and what's going on there. You're memorizing the process. You're memorizing the algebra. So 8, 9, 6. I'm just kind of rounding. On the test, we can all agree, like, hey, let's all round to one decimal place or whatever we decide. Questions on that one? Is the inverse thing, it's not hard. So I don't get why it is so hard for kids. Maybe you guys can fill me in like, oh, this feels weird. So that's maybe what's hard for kids. Or does it feel easy? I don't know. Okay, let's move on to some story problems and we'll be done for the day. Okay, read this problem. It says, okay, if the ramp, this is showing a 30 feet ramp leaning against a wall at a construction site. Okay, it says if the ramp forms a 32-degree angle with the ground. Now remember, there is a vocabulary word. This is called an angle of elevation. Now, fun fact, this is actually also an angle of depression. It's a very common error for kids when they hear angle of depression. Look, watch, to put it right here. Because that just feels right. It's wrong. Angle of elevation and angle of depression are in the same spot. So anytime they say angle of depression, go, I'm not going to be this student. Because that feels like it should be that. It's not that. Angle of depression is right here at the ground. So that creates the triangle. Anyways, so it says, how high above the ground? So what do I put my X here, everyone? What if it said, how far away is it, the ramp from the wall? Then you would have put the X down here. Do you guys see the difference?
Yeah.
It says, if the ramp, how high to the top of the ramp? So I put X there. So you're going to go, this is theta, opposite hypotenuse. Sine of 32 equals opposite over hypotenuse. I skipped showing my work on that one. I just was like, oh, opposite hypotenuse. That's what I was given because we've just done so many today already at this point. And then what we just times the 30 over. 30 sine of 32 equals X. 30 sine of 32 is typed into my calculator, and we get, it's 15.897 feet high. Is that making sense? Now, you do have to be able to draw some story problems sometimes, so you would have to be able to read. If you read that, could you recreate that? I mean, I feel like it should be, it's very literal, these, when you read them, you know. Okay, so look with me at this, okay, because it says, use the diagram of triangle ABC. BC is 12, so let's go fill that in. Oh, they already did. BC is 12, and then it says angle C is 40, so they've already filled that in. If it said find X, you'd go, okay, so X is here, Y is here. We would do opposite. We'd call this opposite and adjacent. So that's tan. So you'd say tan of 40 equals X over 12. And then we would just times 12 over. 12 tan of 40 equals X. While I'm here, I'm going to just set up, I don't want to do Pythagorean theorem, so I'm just going to set up Y. Don't I have adjacent and a hypotenuse? Yeah. So adjacent and hypotenuse, isn't that K? If I'm trying to solve for Y, everyone. I'm not going to do X. I'm going to use 12, obviously. So I feel like people are confused. You guys understand? I'm just going to write down also the statement for Y. Yes or no? Yeah. Okay. So then you're going to say cosine of 40 equals adjacent over hypotenuse. Now, in this case, the algebra is a two-step problem because this time the Y is on bottom. So what would I do first?
Times Y.
Yes, times Y. Then divide by cosine of 40. You're right. Okay, good. And then you would have that. So then you would type in your calculator 12 divided by cosine of 40. That would be your Y. Which would be 15.7. I just rounded to one decimal place. And then you're going to type in 12 tan of 40. 10.1-ish. Okay. Moving on. This one's a little tricky. I want to just do this one. Then we can just call it a day. Honestly, we could probably skip that one, but that's definitely the level that you see more in Sec 3 extended. We can come back to that one, but let's go to 14. The angle of elevation from a point 25 feet from the base of a tree. So draw a tree. This should be your thought process. I'm drawing a tree. Apparently, we're from the base of the tree 25 feet. And an angle of elevation. So I go like this and just draw a right triangle. Angle of elevation. Where is it going? In the bottom left corner, everyone. Yes? Okay. Angle of elevation is 30 degrees. Find the height of the tree. So you got to put X where it wants. X would be here. So then you would say, oh, okay. So then that's opposite and adjacent. Opposite and adjacent. Hypotenuse is across from 90. You're going to assume the tree is standing straight up, unless stated otherwise. So then that'd be tan of 30 equals X over 25. Then you would times 25 over. I think we get the picture overall. I don't know if I need to keep going on all that. Okay, so it's just more and more and more story problems of the same thing. It's like very straightforward. Do you guys need any more? I don't want to waste your time doing stuff you get it. If you get it, but okay. Okay. What if you look at something like this? People way overcomplicate this. Okay. So what would 90 minus? That's a lambda. I don't remember the Greek letter that is. Anyone by chance? Alpha. Oh, alpha. I think it's more alpha because lambda is something like that, but lambda is like that.
I'm so confused.
I don't know. I don't remember the Greek letter. It's been too long since I've been in like calculus where they use them. Okay, sweet. Let's just call it alpha. Now, if you're like, I don't like that, then make it an X. Go, I don't like that, and go X, and then make this an X, and then make this an X. Oh, who cares? It's an alpha. It's a alphabet letter. So if they say find X, you're gonna say, oh, they want me to find an angle, so I need to set up a statement. I can set up any statement I want as long as it's true. So I guess I'll just do sine. Sine of theta equals opposite over hypotenuse. So sine, oh, why am I writing tan? I like literally, that was the weirdest thing. Sine of theta, isn't theta x? So I'm going to go sine of x equals 8 over 17. And then I would inverse both sides, sine inverse both sides. So x is equal to sine inverse of 8/17, and then you would hit second sine 8/17, and that would be 28.1 degrees. Okay, now it says find cosine of 90 minus x. So what angle is that? Think about it. How many degrees are in a full triangle? 180. Isn't this 90 already taken? So isn't that then going to put me, look, 90 minus x, wouldn't that put me right here at this location? Think about why. If there's 180 and I got to take off 90, isn't there only 90 left between here and here? So they're like 90 minus x. You'd go, oh, this is going to be 90 minus 28.1. Isn't that true? So it's just putting you at a different location. It's just a new location. So you go, oh, they just want me to go right here to this angle instead of the 28.1. I'll say that again. 90 minus that would put you at this location because between here and here there are 90 degrees. Are you guys seeing it? Okay. So now you're like, I'm just at this new location. Now I said find cosine. This just is a location. So now find cosine. What is cosine? Adjacent over hypotenuse. What's my adjacent side from purple? Theta. And my hypotenuse is 17. So that would have been my answer on the test. 8/17. And the x we found was 28.1. So answer what they ask of you. But don't let this overcomplicate your brain. It just puts you at the other angle every time. Because depending on where we're at, the sine, cosine, and tangent would be a different statement, right? Okay. All right, it sounds like you guys feel like you've got it. What if you're asked to solve the whole triangle on the test? And I think you are. So let's just do one and then we'll be done. So go to number 10. And then you guys can just go start working on the homework ones. If they say solve the triangle, they want all missing angles, all missing sides. So I just like to be more organized, go like this. And I go, okay, so I need angle A, angle B, angle C. And then I need side A, side B, side C. A lot of those will already be given. So let's just go fill in what we know. Angle A, do we know that? No. How about angle B? 30 degrees. And angle C? 90. Well, then angle A is going to be, yeah, easy. You're saying it's 60? So you did 180 minus 90 minus 30, which is 60 degrees. Okay, cool. Now I could go fill it in on the triangle. I don't have to if I don't want to. Side A. Let's find side A. So I'm going to pick a theta. I can't pick 90, so I'm just going to pick the 30. So to find A, won't this be adjacent? And this will be opposite from 30? So what would I state? Is it so, or is it ka, or is it toa? So you're going to say tangent of 30 degrees equals opposite over adjacent. The adjacent side was A. And now it's basic algebra to get A alone. Well, now times A over. So we have A tan of 30 equals 7. Divide by tan of 30. Then you would type into your calculator. 7 divided by tan of 30 is 12 point. Let's just, for quickness purposes right now, just do whole numbers. So that'd be 12, let's say. So I could write 12 here. Was that side A? Yeah?
What did you times 7? By tangent of 30.
If that's, is this statement wrong?
I don't think so.
Is side A the hypotenuse side? Is that where it's
No, it's the adjacent.
No, it's the adjacent. Look, this is hypotenuse.
Oh, yeah, okay.
And then this is opposite and this is adjacent, right, everyone? And so if that's my statement, tangent of 30 equals 7 over A, then I would first times A up, and then I would divide tangent of 30 over, right? The basic algebra steps there.
I can't
Okay.
She specifically told me not to.
Oh, I see. I was looking at like the big A and not like the small A.
Oh, yeah, you gotta look at side lengths are generally written with lowercase letters and angles just to keep things straight. It's just become a norm in math to write them with angles with uppercase letters. So then, do you guys want to use Pythagorean theorem or do you want to just use trig? Let's do trig, okay. Then that would be opposite over hypotenuse. Is that sine? So sine of 30 equals opposite over hypotenuse. So then we'll times our c up. So it'd be c sine of 30 equals 7. We'll then divide by sine of 30. We'll get the same answer either way because math is math. It's correct. It's just which way do you want to do? 7 divided by sine of 30 is 14. All right, so that's the end of the lesson. I mean, honestly, like I said, right triangle trig does come up a lot next year. If you have really good foundations, it makes moving into the hard stuff a lot easier. So I really am hoping you'll retain it over the summer. Your homework, whoa, was that your part of your homework that we were doing there?
Yeah.
Well, do the rest. Didn't mean to take off your problems.
No, that's fine.
I thought I said homework started somewhere, so I just kept going, I guess. Where? You're right. Where the heck does it start? I swear I labeled it. Oh, worksheet. So you can just start at the worksheet and move your way down. And then, if you're like a person who, let's talk about the final exam.